So I will jump right in. So we're going to talk about, what we can learn from analyzing, tremendous amount of downloads of open source on Scarf's platform, what we can learn from them, et cetera. So just to quickly introduce myself. As Evan said, I'm the founder and CEO of Scarf. My background is as an open source maintainer, really into functional programming and the Haskell community, if you're into that sort of thing. But quickly about Scarf itself. It's a small startup. We're about 5 years old. We do a lot of analytics and insights around download metrics, usage metrics, all around open source projects. So we're a little bit in a more meta world about this rather than talking about the analytics stack itself. We're going to talk about what we can learn across all these things that we are helping track around the open source community. And we're all about trying to, promote open source sustainability and help, companies that commercialize open source and help open source projects have more sustainability with their own work. So what we will talk about today, we'll talk a little bit about the data itself, how it was collected, how we process and analyze it, et cetera. We'll talk about the trends that have popped up in that data, and then what we can learn and why we should care. All right. So a little bit about the data. We're looking at about 2,500 open source packages across, across the portfolio of things that are being tracked with Scarf. It's a lot of different kinds of artifacts, but mainly the bulk of this is made up of things like Docker containers, things like Helm charts, binaries and tarballs that might be on like GitHub releases or these kinds of things, language level packages like JavaScript and Python packages, and even a couple of Terraform modules. The creators of these software packages, we tried to keep it, fairly diverse. And so there's both commercial and non-commercial open source. There's single vendor and multi-vendor open source. And a significant amount of these also are held in foundations like the Apache Software Foundation, the Linux Foundation, or the CNCF, or others. And so hopes to be like a good mix of things. In the time window of this analysis, the title is a lie, I guess. It's actually 2.7 billion downloads that we're looking at for the time frame. And it's a little over 19 million anonymized users, I'll say in quote. We use the technical term in origin ID, but we'll talk about what exactly that means and what Scarf will do with all of this information. So, when a download of a particular software package happens on our platform, we're going to do, analysis on the request, including the IP address metadata, which we will look up from multiple different sources of that kind of information. So that's things like the Whois records, that's vendors like IP Registry, Clearbit, Sense, a couple others as well. And what Scarf will do is take all that metadata, process it, and provide that to the maintainers of this kind of open source. And we do that in kind of, a GDPR compliant way, et cetera. So a little bit more on the specifics of what that looks like. We have an open source project of our own called Scarf Gateway. Scarf Gateway can sit in front of various different registries, pretty much any URL on the internet. And so what users will do is like they will Docker pull on an image that will basically pass through Scarf Gateway and then get redirected to wherever the maintainers are hosting that software. So you can Docker pull through Scarf Gateway. You can pip install through Scarf Gateway. You can, curl a binary through Scarf Gateway, et cetera. And, that makes up the bulk of this kind of data. We also do support things like post-install telemetry. So we have a library called Scarf.js, which will send post-install, quick post-install hook with like the version of the package that got installed. We then process that metadata. We get the metadata associated with the IP address, and then we anonymize it. So we hard delete the IP from Scarf's system, remove that PII, and what we're left with is kind of this useful metadata about the download, what resource was being downloaded from where, these kinds of things. Okay, so In terms of the volume of data here, so this analysis was on stuff from 2022 through Q1 of this year. A lot of this growth is more attributable to just Scarf, working with more and more projects over time. The most recent quarter in this analysis had crossed about close to 700 million downloads of various packages during that quarter, but you can kind of see the general arc here. So one really interesting thing here, right? So, if you are, say, distributing a database, or some kind of application, maybe you do it with Docker, maybe you do it with some other language level package, you might want to know, well, how many users are behind this? And so, one kind of initial like low hanging fruit of questions to answer with this data is, what do we mean by, a user? This is all anonymous traffic, right? No one's signing into anything to download open source. And so we want to have some notion of uniqueness. And essentially, the solution that we have come to in Scarf is that you need to have multiple notions of uniqueness to do different kinds of useful analytics here. And so we have two notions of uniqueness. One we call an endpoint ID, and one we call an origin ID. The endpoint ID is essentially just hashing the IP address. So in Scarf, that'll get salted, that'll get, obfuscated, et cetera. So no, nothing can be tied back to the original IP address. However, we do get something that is stable and when a user re-downloads a piece of software, you can then attribute it at the IP address level. We then have to go a little bit further, right? Because the idea is that, you may have, a whole team of developers downloading a piece of software from one corporate egress. Those are all going to have the same endpoint ID, but we can do better, right? So we can then go to what we call an origin ID, which then incorporates things like the user agent of the request. And so, if you have two different versions of Python that download the same package from the same network, well, you can, those are two different sources of traffic, and you can talk about those. And so these will both, undercount and overcount in different ways. The endpoint IDs might undercount on a corporate network, or these kind or like say like a WeWork, or these types of networks where there's a lot of different people. Origin IDs might overcount in some ways, right? So like if I look at if I download something in my browser and then I curl it, that's going to be two unique origin IDs, which may or may not be what you want. And so the idea is that by pairing up these two notions of uniqueness, you can then start to talk about it in different ways depending on what the situation calls for. We will come back to these topics here as well. Let's see. So continuing on, it's interesting to talk about like what does the artifact registry actually see here, and like what other information might we want to look at. And so whether you're distributing software on npm or Docker Hub or PyPI or wherever this might be, the registry tends to see a few different things. So obviously there's the resource that's being downloaded. There's the time series of when it got downloaded, and what the overall time series looks like. There's the user agent behind any given request. So what kind of client is actually connecting to download this thing? You might get other HTTP headers. So there's things like do not track headers. There's things like, there's like cache control. There's a lot of different things in the headers that may be of interest here. And then there's the IP address, right? And so this is the set of data that the registry will see. Historically, the registries give very little information beyond just that download count, but there's a lot more that it can be doing. So here's the things that we can learn just from this kind of analysis. So one thing that I think is, just for starters here, open source is being used almost everywhere around the world. So for those folks here who are maintaining open source, I think the one highlight of this is that your software probably has a much bigger impact on the world than you might realize. And so, Scarf has seen downloads from nearly every single country on the planet, with the exception of just a few, which are highlighted highlighted in red here. So Western Sahara, Antarctic lands, and like just very few countries that have not been seen by Scarf using open source. And again, this is just from a sample of those 2.7 billion downloads, which is nowhere near comprehensive. But what we can learn from that is that open source will be used just about everywhere. And it gets even to the most extreme environments and areas, right? So we've seen downloads from very close to the North Pole, from very close to the South Pole, as IP address enrichment starts to work in space and, in other places, we'll continue to see kind of the expansion of open source usage to be pretty much wherever there are, wherever there are people, which I think is kind of interesting to think about as well. We've seen a lot of governments using open source as well. We've seen about 65% of the world's national governments downloading open source through Scarf. We'll talk a little bit more about kind of the mechanics of how an IP can be tied to a specific organization. We'll get to that in a sec. But the idea here is that when we see that an IP address is tied to a government agency, this graph is showing the number of unique institutions, unique organizations from each country that we've seen. And so because Scarf is is an American company, and a lot of the projects that we work with, a lot of American maintainers, I think we see definitely this data skews, towards the Americas, but we also see very heavy public sector usage of open source in Brazil. We see that in Australia. We see that in Russia and Germany, and in a lot of Europe, India as well. But really, this kind of, I would say, broadly covers South America, Asia, Europe, Australia, and then we see a lot of rise, from Africa as well. One question I see in the chat here: are there active efforts to get someone from those last two countries to use open source? Nothing that Scarf is doing right now is addressing this at the moment, I would say, but hopefully raising this kind of awareness may help. But if you're someone who is promoting open source in these countries, definitely come talk to us. We'd love to help. Cool. So the mechanics of this. Anytime Scarf sees a download, any request that comes in, the IP address metadata will bucket those connections. What we call a connection type will get bucketed into a few different categories. So the broadest of which is just an ISP. It's just, this might be someone on a home network. This might be just, any time where it just says like Comcast or, Broadcom or these kinds of things where you don't really know much other than it's an internet service provider, which basically, doesn't really give you much information. The next biggest category is hosting. So this means that the download came from like an EC2 instance, a GCP instance, this kind of thing. We see very high volume, very high, repeat downloads from the hosting environments. If you have a cluster that spins up and might, pull down a piece of software on 1,000 different nodes, that will really increase the green here. The blue, business is one connection type. This is often where a lot of the meat of the utility of some of this data comes from. But then we also see downloads from educational institutions, primarily universities, and then government, which is a very, very small slice of this. But, like we were seeing kind of the previous map, that it's very, very geographically distributed. And the interesting thing with the government trends in the usage behavior is that we rarely see a government agency download the same piece of software twice. And this is because you see pretty aggressive, use of internal registries and caching and these kinds of things. Very similar to what you see within like the largest, the Fortune 50 companies also, tend to be using internal registries where you're rarely going to see a download twice of the same, version of a particular piece of software. But the really cool thing here is that we've tracked about 1.4 million corporate domains associated with these downloads. So 1.4 million businesses here using and downloading open source. There's a wealth of data here that can help prop up, or that can really help open source businesses, grow, be sustainable, and commercialize more effectively with their commercial entities while still keeping the code free and open for everybody. This is really the important thing here is that there's a lot of data here that's really quite valuable to the businesses that commercialize open source that helps them keep the software open. A few different questions that are coming in here. Across all projects, do you have a read on the adoption growth of open source and whether or not it might be winning against proprietary software? This is a really good question. There's a few different pieces of this. I mean, on the one hand, we don't really all the proprietary software out there, we don't really have a great view into that, but we do see generally growth across the board in just about every country. More open source is being used over time. Things like AI are actually increasing this a lot, where you have a lot of, the big, big enterprises that are doing a lot more, AI work, and they do a lot more open source as a result of that. In general, the way that we read a lot of this data is that most organizations are using more open source over time, not less. Open source is definitely winning, but proprietary is also probably growing as well as we use more and more software in general over time. Let's see, the second question that came in, how did you convince enterprise users to adopt an open source solution, and what challenges did you face in this process? I guess one thing to clear up here is that Scarf is not necessarily advocating that anyone use the open source that's being distributed on our platform. The maintainers of open source start tracking their stuff with Scarf, and then their users are using it however they're using it. And so that's one really interesting lesson here, is that when a open source project starts to make their software available on Scarf's gateway, they just are telling their users, hey, here's where you get our software. You get it from, this link, not wherever you were getting it from before, or maybe they do, maybe they don't. And that's where people are going to fetch the software. And so these 2.7 billion downloads are all places where people were going to, say, Docker Hub or PyPI before. Now they're going to, through Scarf. And that's just because that's where the maintainer said that the software was available, like in their documentation or in their, Helm charts or these kinds of things. People will go to wherever you tell them to go to get your software. And that's, I think, a very powerful lesson here as well. On that note, 95% of the Fortune 500 has been seen downloading open source packages on Scarf. There's a couple things to say about this. One, obviously, open source is propping up, the software stack of basically the entire world. Here is the proof. The highest numbers that we've seen from any survey have topped out between 89 and 91% of enterprises that are using open source. Scarf has seen 95%. And one thing that we can learn from this is that surveys are good, but tracking this stuff automatically is better. This is an approach that has, shown to be able to start to track this stuff, in real time, in the enterprise, this kind of thing. We want to advocate for more of the automatic data collection and less of the, survey-based data collection, because the survey-based data collection is skewed. There's sampling bias. It's hard to design a good survey. There's a lot of reasons why it can be very advantageous to collect data in this fashion rather than surveys. However, sometimes you got to do a survey. The public clouds that we see, so when the connection type is equal to hosting, we see very, very broad dominance of AWS in our data. We see a lot of traffic from Google. We see a lot of traffic from Hetzner. There's quite a bit of Azure as well, but for very specific reasons, it's a little bit harder to tell when something is coming specifically from Azure versus versus Microsoft broadly. And so the data is a little bit messier there and has been excluded from these results. But by and large, if you are wanting to optimize for public cloud adoption, our data would say you should start with Amazon. Not necessarily a very surprising result to some, but that is what the data shows. If you are publishing containers, this is one where there's been a lot of deltas in the market here over time. Docker Hub seems to be the dominant registry, not by a huge margin though. GHCR has been largely, interestingly, earlier in Scarf's journey, we saw GHCR really gaining market share very quickly. Now Docker Hub is starting to take some of that market share back. But in general, if you are publishing containers, most of your users will probably want to go to Docker Hub or GHCR. Key.io from Red Hat is the only notable third player. Every other registry was not big enough to show it in this pie chart. So that's how the traffic has looked. One really interesting thing that we see in the data is that we're able to detect when the download is coming from a VPN that is well known, and so at least 2.2% of this traffic came from a recognizable VPN. Obviously people can roll their own VPNs. There's much smaller VPN providers that maybe Scarf was not able to detect. So I wouldn't guess that it would be anything above 2.5% of the traffic coming from VPNs. But that's typically what we're seeing. Very, very little of this traffic came through Tor or these kinds of other relays that are masking the identity of the traffic. But by and large, you can imagine that there's a small fraction of your users are downloading through VPNs. And so, any of this VPN traffic would also potentially obfuscate the location or the business behind it, these kinds of things. One of the lessons from this data that I think is a really important takeaway from this is that if you're looking at the downloads of, say, your open source database, your open source developer tool on whatever registry you might host on, your total downloads versus your unique users look very different. So in this red line, we are looking at origin IDs. So that is, potentially an overcount in some cases, potentially more correct in other cases, or more exact, I should say, in other cases. The ratio of downloads to unique users is quite big. It tends to be different by an order of 2 to 3 orders of magnitude. So for those that had 600 million downloads, we were seeing about 7 million users behind that traffic. Total download volume versus unique user volume can look very different, and sometimes the total download volume can be very misleading. We see this sometimes be very disappointing for projects. We sometimes see this be highly encouraging for projects. It really depends. The ratio tends to be about 100 to 1. Some of the best, it's not necessarily good or bad, but the lowest ratio of certain packages that we see on the Scarf platform is closer to 15 to 1 in terms of total downloads to unique users behind it. But these things are very different, and that tends to be very surprising for folks. And sometimes you'll see surges in your downloads, which could be really exciting, but they're just not real. One of the organizations that we work with, linuxserver.io, this really great organization, they do a lot of packaging of various software components. They Dockerize them so people can use them with Docker. They found that over half of their pulls of certain projects came from about 20 users. They had about 20 billion downloads of all of their pulls of all their Docker containers when they started working with us. And, they saw multiple trends in the data. So both, multiple increases, huge blips, and drop-offs that had nothing to do with the end users. There were no end user changes that were really notable, but huge changes in the overall download volume. And then for other packages, they correlate very tightly. And the idea here is you just don't really know. If you're just looking at download volume, you just don't really know whether or not there was real user growth behind it. It's just the case that often there's people who are downloading over and over. There's CI pipelines. There's a lot of reasons that these numbers get very, very inflated that have nothing to do with real user growth. Sometimes this is a really hard reality to break the news to certain users. But, it's really interesting to think about how much time and resources have we wasted by not understanding this, right? Sometimes VCs will put tens of millions of dollars into a company on the download numbers, and they're just not accurate. They're just very misleading sometimes. And I think this is a really important wake-up call for us in the open source world. And this is because there's a lot of, there's container agents that will continually pull for updates. There's artifact mirrors, there's CI/CD pipelines, there's there's web crawlers, there's all sorts of things. And so we see a lot of highly, I would say, offending user agents here that make up for a huge inflation of some of these stats sometimes. And there's things like RenovateBot and Scopio and Diune where they will just pull the registry over and over and over to check for updates, and they download the thing again when there's an update. And these agents are not supposed to be doing, for instance, in the Docker world, you're supposed to do head requests on a manifest, and the registry is not supposed to count head requests as downloads. However, some of the old clients will not do head requests. They'll do get requests over and over and over, and the registry increases the pull counts over and over and over. And by disambiguating some of these things with the origin IDs and the endpoint IDs, you're able to really deduplicate a lot of this, which is really important to get a better sense of what the real downloads actually look like. One request to the maintainers here is that what we see really firsthand is that some user agents are really exceptionally helpful for this kind of analysis. Pip is a great example of this, where Pip will actually put a whole JSON payload into the user agent. So it's both human and machine readable. It even has amazing things like a CI flag. And so Scarf's actually able to tell you when we're seeing stuff from a CI pipeline versus not a CI pipeline. Even things like, the version of like Rust that it gets compiled with, the OpenSSL it gets compiled with. This is exceptionally useful if you're a maintainer. You get a lot of useful stuff out of this. And I beg of you, maintainers out here, please put more useful information into your user agents. This really helps, really helps the maintainers when they use tools like Scarf. It really helps those managing registries and other web services to cut down on, spam, detect DDoSing, these kinds of things. Please put more info into the user agents. It's super helpful. We see a lot of other good ones, like the Docker client does a really good job of this. Homebrew does a really good job of this, where you can see information about like what the build was compiled with, et cetera. And then you see really bad ones like GoHTTP client. This is Kubernetes usually. Just GoHTTP client, nothing else. Bummer. I gotta get moving quickly here. People don't upgrade versions like you might expect is one thing that we see a lot of. So of all the Docker containers that are downloaded on Scarf, 80% of those downloads are just to latest. It's not pinned. These users will get whatever version you push to them. So if you push a breaking change, these users, it's going to break for them the next time they download. However, for those that are not on like an unpinned dependency and they are pinning to a specific version of a given piece of software, the majority of those users will never upgrade. Never, not once. They're never going to download something again. This is really important because if you have a vulnerability in your database, in your library, in your tool, and you cut a new release with a security patch and you're just waiting for everyone to upgrade, a lot of people are never going to upgrade. You're never going to see them again. The ones that are actually going to ever download a new version of that is less than half. And this is because a lot of people will just try out the software and maybe they churn, you never see them again. But even of your real, production grade users, they're going to be very slow to upgrade in general if they're using your thing in production. Unfortunate reality. And so, why does this matter, right? So we talked about a lot of trends here. The work that we do as open source maintainers, all the tools that we're talking about here at this conference today, we can all deliver much better software more effectively if we have better data about how this stuff is actually being used. Changing attitudes in this ecosystem can be really good for open source, maintenance and feasibility. And the really interesting thing is that like this data, the registries already have this data, but they're just not sharing it with the maintainers. And that's why things like Scarf exist to help to make sure that the maintainers actually get this data. This here on the right and here on the left is what you might see if you're a Docker Hub maintainer or an NPM package maintainer. You just see this download count, but as we've seen today, these numbers can be highly, highly misleading. And so if we want to see less companies switching their license, there's a lot of databases that have done this in the last few years. If we want to see less of this, we need to more systemically support open source businesses and more systemically support these projects to have the information they need to do their jobs more effectively. So I hope to see less rug pulling, less license changes, less open source businesses struggling to find sustainability for their projects, and more data-driven open source maintenance, more data-driven open source commercialization, so we can keep the software open for everybody. So just to wrap up on this stuff, for those who are maintaining open source listening to this talk, your work probably has a much bigger impact on the world than you realize. Most people are never going to come talk to you and thank you for your work, but that doesn't mean that they're not using it and benefiting from it. Tracking the stuff can be really, really important to building a business around open source. There's so many companies relying on open source. There's so many governments relying on open source. And if we can more feasibly connect the maintainers to their users, we will see a more sustainable open source ecosystem with less folks moving away from open source. And so, yeah, I hope this, really makes it more clear that we can collect this data in a way that is privacy conscious, is not invasive, and really moves the needle for helping open source maintainers do their jobs more effectively and foster a more open ecosystem of software. So that's all I've got. Thanks so much.